Thank you so much for joining this lesson. We are doing a continuation on the Kenya National Mathematics Gurus Examination Council Mathematics Paper 2 in preparation for the KCSE 2026. So kindly continue following up. Remember to subscribe. Remember to share so that you may invite a friend. Now we're going directly to the section 2 of this paper. We've already covered and uploaded the section 1. So I request those who have not watched, kindly take your time and check the section 1. These are very wonderful questions. We have simplified every item in the section 1. So allow me go directly to the section 2 of this paper. Yeah, number 17. We are told that OABC is a parallelogram with vertices. You can see the vertices stated there. I think there is a typing error. This is supposed to be our O, then A, B, C. Yeah, we don't have any D anywhere. Then we are told that O prime, A prime, B prime, C prime is the image of OABC under the matrix of transformation 0, -1, 1, 0. Part A, find the coordinates of O prime, A prime, B prime, C prime. We're supposed to recall that a matrix of transformation multiplied by the object gives us the image. And with that, we just have to write the matrix here, 0, -1, 1, 0. Then now we write O, A, B, C. We write the coordinates there. If it is O, we write it as a column vector 3, 1. If it is B, 2. If it is A, 2, 1. Is it 2, 1 or 2, 4? If it is B, 4, 3. If it is C, 5, 1. Yeah. So when we multiply these two matrices, we shall get the coordinates of the image. So O prime shall be there, A prime, B prime, and C prime. Yeah, so let's now get into the multiplication. We know very well to multiply matrices, you need to multiply a row times a matrix. So when we multiply the first row and the first column, we shall get the first element on the answer matrix. So 0 by 3 and -1 by 1. That gives us -1. You see that? We go to the next. For A, we use the first row and the second column like that. So 0 by 2 and -1 by 4. We get -4. The next at B, that is the column at B. So we use 0 by 4 and -1 by 3. We get -3. Then again, for C, then the last on the upper side, we shall use 0 by 5 plus -1 by 1. So we get -1. Then now we check the Y row. So this is the row times the respective columns. So we'll be starting with 1 by 3 and 0 by 1 for coordinates of O. So 1 by 3, we get 3, and 0 by 1, you add, you remain with 3. Then again, the same row times the next column. So it will be 1 by 2. It will be now 1 times 2 and 0 times 4. So you get the 2 at that point. The next shall be 1 by 4 and 0 by 3. We get 4. 1 by 5 and 0 by 1. You get 5. Like that. So we have them that way. That means we can now state the coordinates. You know, when they are a matrix like that, You've not yet stated the matrix. This is the stating of the matrix now. -4, 2, then B prime is a -3, 4, and finally C shall be -1, 5. Perfectly done. Now look at the question in part A. We are told to draw both OABC and the image on the grid that has been provided. So allow me first to come up with the axis, the vertical axis. And then we also come up with a horizontal axis and we plot the coordinates. Then join them to come up with our figures. 0. So we have 1, 2, 3, 4, 5, 6, 7. Can also have 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. -1, -2, -3, -4, -5, -6. So we have the Cartesian plane. This is the y-axis. This is the x-axis, properly labeled, scale properly chosen. So coordinate O, sorry, we have it as a 3, 1. Allow me use the black for the coordinates. 3, 1. So 3, 1 is here. That's our O. Then A is 2, 4. So 2, 4 shall be here. That's our A. Then B is what? 4, 3. So 4, 3. That's our B. And C is 5, 1. This is where 5, 1 is. That's our C. So we now supposed to connect all of them. Allow me use a blue. So from O to A, then to B, actually it's just a contralateral. I've discovered it's not even a parallelogram according to what the examiner had said. It's just a figure. It's just a contralateral, four-sided figure like that. So we already have the contralateral. Okay, the contralateral, a four-sided figure, the first one. The image, we can see the coordinates. So we need -1, 3. -1, 3 is here. So that's where O prime shall be. Then we go to A, which is -4, 2. -4, 2 is a coordinate at this point, and this shall be A prime. Then for B prime, it's -3, 4. -3, +4 is here. So this is where B prime shall be. And for C, it shall be -1, +5, which is here. -1, +5. So C prime shall be at that point. So now I can use a different color like red to join all of them. So after the transformation, this is where the image has been mapped by the transformation matrix that was used that way. So we have the object and the first image. Then part B of the question, which has a Roman 1 and 2. Find O double prime, B double prime, A double prime, C double prime, the image of the first image under the transformation matrix 1, 0, 0, -1 for 1 mark. And after that, you are told on the same grid, you draw it. So allow me apply the same matrix times the object so that you may get the image. So we need to have 0. Okay, it starts with the matrix is here. So it's 1, 0, 1, 0, then 0, -1, like that. Then what are we multiplying? The first image that we already got, -1, 3, -1, 3, -4, 2. Is it so? Yeah, then -3, 4, then -1, 5. Can confirm that. -1, 5 here, -3, 4. That way. Then we now compute again multiplication of matrices to get the image. So we start. The first row again. The first row here should multiply every column. So we start with the first column. So 1 by -1, then 0 by 3, and you add. 1 by -1, we get -1. And when you multiply 0 and 3, you get a 0. So when you add, you still get the -1. We go to the next column, whereby it should be 1 by -4, we get -4. 0 by 2, you get a 0. And you add, you get -4. The next should be the same row by the next column. 1 by -3, we get -3. And you just write your -3 because 0 by 4 becomes a 0 and you add. And the last column here to be 1 by -1, you get a -1. Then 0 by 5, it becomes a 0. On the X row, the row that gives us the X coordinates is the second row here. So now it will be the second row times the second row multiplied by the respective columns. We start 0 by -1, we get a 0. -3 or -1 by 3, we get a -3. We go to the next. 0 by -4 and -1 by 2, it becomes a -2. 0 by -3 and -1 by 4, it becomes a -4. And finally, 0 by -1 and -1 by 5, it becomes a -5. So you see, the coordinates can now be outlined. The second image, it will be -1, -3. And for A, it will be -4, -2. For B, it shall be -3, -4. And finally, you will close the brackets. And finally, C double prime shall be -1 by -5. Then you plot according to the second instruction. On the same grid, you draw. So -1, -3, you plot. -1, -3 plotted. That becomes our O double prime. The other thing is -4, -2. -4, -2 shall be at this point. So this is our A double prime, like that. Then for B, it shall be -3, -4. -3, -4, which is at this point. This is our B double prime. And finally, we have -1, -5. -1, -5 shall be at this point. So this is our C double prime, and you join all of them. So let me use a black for this time around. From A to O, let me draw a straight line. From A to B, then B to C, then finally C to O. That is it. So we have the three quadrilaterals. Three quadrilaterals. That is how they are supposed to feature on the grid. And finally, we got a question, ladies and gentlemen, in part C that tells us to find the single matrix that maps O double prime, A double prime, B double prime onto OABC, the first quadrilateral. How can we have this one, the last one that we've drawn, being mapped to the first one that we started with, to the original object? This is a very easy thing. We are supposed to apply the same principle this way. We apply the same. And how do we apply that? By saying that a matrix times object should give us the image. And we are having matrix being unknown. That is what you are finding. So the elements in our matrix, we can let them to be unknowns. A, B, C, D, like that, multiplied by the last image that we are already having here, -1, -3, -4, -2, -3, -4, -1, -5. This is equal to, so we want this to become, the first quadrilateral, whereby we know the coordinates are there. It was 3, 1, 2, 4. It was a 3, 1, 2, 4, 4, 3, and 5, 1. Like that. Is it 5, 1? Yeah, 4, 3, and 5, 1. That way. So that is it now. That is the expression. That is the equation. This is what we are supposed now to solve until we get the unknown matrix, till we get the elements in the unknown matrix here. Therefore, we start with this row times the first column here should give us the first element. We know that. So A by -1, it becomes -A, and B by -3, it becomes -3B. This is supposed to give us 3. This is equation 1. We can use A at B again using the second column, so that we may get another equation in A and B. Therefore, A by -4, that is -4A. Then B by -2, that is -2, the value of B. This is supposed to give us the second element, which is 2. And through that, we have our second equation. So when we solve the two equations simultaneously, we shall get the values of A and B. Yeah, we shall get the values of A and B. So we can check that. Let us check the values of A and B. So the values of A and B now shall be, it's a simultaneous equation, it's a pair of simultaneous. So we can use any of the methods. We have matrix methods, we have elimination, we have substitution method, and such. So allow me prefer the substitution method, so that I say from equation 1, the value of A can be expressed as, I'm taking A to be positive on the left, so that I have -3B, then -3, that way. So that equation 2 becomes -4, and instead of A, you have -3B -3, then -2B, and this is equal to 2, that way. So with this, we can find the value of B when we talk about negative Yeah, let me manage the space in the best knowledge possible. This will be positive 12b, then positive 12, then minus 2b equals to 2. When we group terms together, this will be 10, the value of b. This will be negative value of 10. So that the value of b equals to negative 1 when you divide through by 10. If that is the value of b, then the value of a can also be gotten using this relation here. The value of a then equals to the value of a equals to minus 3, the value of b, which is a negative 1, then minus 3. So what are we having there? Positive 3 minus 3. Ladies and gentlemen, I'm getting a 0. So as b is negative 1, a equals a 0. So we have two elements of the matrix of transformation that maps the second image to the first quadrilateral. We can proceed to find the values of C and D, which is our second row that gives us the Y components of the answer. So when we take this row now, CD, and we multiply by the first column, we should get the first element on the answer matrix on the Y, we get a positive 1. So C by negative 1 and D by negative 3. So negative C minus 3D. Negative C minus 3, the value of D, that's equal to 1. That's another equation. Then again, equations involving C and D, we can use the second column here to multiply the same row. So we talk about C by negative 4 and D by negative 2 to give us the second element on the Y in the answer matrix. So negative 4 and negative 2. Negative 4 C and negative 2 D to give us 4. This is a second equation. Is that clear? Yes. Oh, I hope we are together there. So from this, we solve. Allow me now solve for the values of C and D. So from the first equation, the value of C, when you take C to the right, it will become positive. So that we have negative 3, the value of D, then minus 1 is also taken to the side that has negative 3D. So with this, now we can talk about negative 4, and instead of C, negative 3D minus 1 minus 2D, this is equal to 4. That is the second equation now. Positive 12, the value of D, positive 4 minus 2D, this is equal to positive 4. Grouping terms together will give us 10, the value of D, and this is equal to 0. So D equals 2. When we take 0 and we divide it by 10, we are getting a 0. If the value of D is a 0, then the value of C can be gotten by the fact that we have an expression there for C. So C equals to negative 3, the value of D minus 1. This is a negative 1. So we have the value of C as negative 1, the value of D is a 0. And the matrix that was unknown now is known. AB is a 0, negative 1. Then CD shall be negative 1, 0. Negative 1, 0, like that. So we have our matrix now, which is responsible of transforming the final image to the original object. A very simple question, very simple. So that's how the first 10 marks in this paper are supposed to be obtained. A very good question. Now we are transitioning to a statistics question, number 18. It's good for you to know that as you prepare for the KCSE, you will never lack a question from statistics. Should I repeat that statement? As you continue preparing for the KCSE 2026, there are topics that must appear, that must feature in the KCSE. Any topic that appears twice in the curriculum. For instance, we have statistics 1 and statistics 2. I'm clearing the space here. We have commercial arithmetic 1, commercial arithmetic 2. We have vector 1, we have vector 2. Such topics, quadratic expressions again in book 3. Such topics must feature in the national evaluation. They are so broad. Trigonometry, we have trigonometry 1, 2, and 3. Whether in section 1, section 2, these topics must feature. And therefore, I want to urge my listeners, teachers, and students, if you're listening to me, kindly invest in such topics. You shall never regret. As we get to number 18, please be invited to our serious programs. You can continue following us on our main platform. That is our YouTube channel, Shifting Grades Online School. You can enjoy our serious interactive lessons like the one that we are having. Remember to subscribe. Actually, we are now the best online platform. We are beyond 85,000 subscribers, and I want to appreciate you for that. Please support us towards the first 100,000 subscribers. So by simply subscribing and inviting your friends to our programs. On top of this, we have our online classes that happen via Google Meet. Yeah, Google Meet, one of the most interactive forums where you ask questions, where you can respond to questions, where you interact with teachers and students, just like an ordinary classroom. Reach out for registration through our number, which is already attached on the board, 0704 15 3366. And I'm going to announce this, ladies and gentlemen. In the month of August, we shall have examiner session for both KJSEA and KCSE. So if you have a friend preparing for the national examinations this year, KJSEA and the KCSE, we shall have the best session with examiners in all the subjects and learning areas, taking you through the composition of every paper, the marking techniques of every paper, and every trick that you're supposed to know about the NEC assessments. So kindly reach out so that you guys may be enrolled. But for the April, we shall be interacting in mathematics, sciences, and the languages. Our team of very dedicated teachers is ready to occupy you for 2 weeks in the month of April. So please enroll to our programs. Thank you. Thank you so much. Please remember to subscribe to our channel. Number 18. The table below shows the distribution of marks scored by a group of 100 candidates in mathematics national examination. Calculate the quartile deviation of the data above. Quartile deviation. Quartile deviation is also called the semi-interquartile range. Quartile deviation is given by Q3 minus Q1 out of 2. You know, Q3 minus Q1, that is called interquartile range. But when we divide the interquartile range by 2, it becomes the semi-interquartile range. So now, semi-interquartile range is what we are calling quartile deviation. Allow me first manipulate this data by writing it in columns and not rows, so that we'll be able to understand it keenly. Yeah. This is very recommended. So we can have our frequencies there. And after frequencies, we can talk CF. Then later we'll be adding more columns as we continue discussing these questions. So we will add more columns, but let me start with the classes, then the F, then the cumulative frequencies. 21 to 30, 6, 31 to 40, 18, then 41 to 50. Is it 27? Yes. Then 51 to 60. We have 36 of them. Then 61 to 70. We have 10 of them, and 71 to 80. We have 3 of them. So cumulative frequency now shall be given by the first frequency, which is a 6. Then now in the next class, cumulative frequency shall be 6 plus 18, which is a 24. Then 24 plus 27, we get 51. And 51 plus 36. 51 plus 36, we get, is it 87? Then 97 after adding 10, and finally 100, yeah. So those are the cumulative frequencies. Please allow me to distinguish every class from the other by doing these horizontal lines. You know, as we continue broadening the data, we might have some classes mixing up with others. So this is for the safety of the data. Okay, I'm going to use the spaces anyway. The spaces below these. There is the general formula. You know, when we talk about quartiles, we have 3 quartiles. We have the second quartile, or Q2. We have a second quartile, that is what we call Q2, and it is the median. Q2 is also called the middle quartile. Then we have the upper quartile, which is Q3. We have the lower quartile, which is Q1. The quartiles divide the data into 4 portions, but we have the median that divides the data into 2, which we call the middle quartile. So I will start by working out what we call the upper quartile. Middle quartile is even discussed in mathematics paper 1, that is form 2 work. So remind yourself the formula for middle quartile. Median, which is called Q2, the middle quartile, it's given by lower class boundary of the median class plus n out of 2 minus, is it n out of 2, or we can write it this way because I want people to understand. Let me show you how to state the formula in a better way. This way, I will clear up the space here so that people may understand the formula in each of the quartiles. And I'm starting by a quartile that we will not even write it here. A quartile that we are not even to use it. The median is called the Q2. To get the Q2, we need lower class boundary plus half of the total frequency minus cumulative frequency in the class just before the median class. Then everything is divided by frequency of the median class, and everything here we multiply by the class length. Class length is also called the class interval. So half of the total frequency, this gives us the middle quartile, rather the median. Now from this, we can talk about the upper quartile, which is called the Q3. Q3 is given by lower class boundary of the Q3 class plus 3/4 of the total frequency minus cumulative frequency just before the Q3 class out of F. Then everything here should be multiplied by the class length, like that. After that, we have the Q1. The Q1, we need it. We need Q1. So for us to get Q1, which is the lower quartile, We need lower class boundary plus a quarter of the total frequency minus cumulative frequency just before the Q1 class out of frequency of the Q1 class, and all this part should be multiplied by the class length of the Q1 class. Now say what we need is Q3 and Q1 in this case. So that Q1, okay, so that Q3 minus Q1 divided by 2 gives us quartile deviation. Before we get to the substituting of the formula, we have to identify the respective classes. The class for Q1, which is the class for Q1? Total frequency is 100. So we pick 3/4 of 100. 3/4 of 100. This is 75. Then we check using the CF. Where is 75 lying? Where is the 76th student? Where is the 76th student? We have a 6, we have 24, 51. We are yet to be at 75. So the 75th is lying in this class. So this becomes our Q3 class, where the 75th student is lying. That's the class that we shall be dealing with. Therefore, for us to get Q3, let me substitute here. For us to get Q3, we need the lower class boundary. How do we get lower class boundaries, ladies and gentlemen? The lower class boundary should be the lower limit minus the upper limit of the previous class divided by 2. Lower limit plus upper limit of the previous, and you divide by 2. So we take 51 and 50, then we divide them by 2. We get 50.5. That becomes lower boundary of a class. So 50.5 becomes our lower boundary plus 3/4 of 100 minus cumulative frequency just before this class. Just before our class, we have a 51. Divide by frequency of this class. You know, frequency of this class is already 36. You can see it there. Multiplied by the class length, which is 10. Class length is 10 because we need upper boundary minus lower boundary. Upper boundary is 60.5 minus lower boundary 50.5, we get 10. So we can get the value of our Q3. So I need to take 75 and I subtract 51. Then I multiply by 10 as I divide by 36. That gives me 6.666 recurring. So I'll be having 50.5 plus 6.666 recurring, you know. So to 4SF, I can round it off like that. And I add 50.5. So I'm getting 57.17 or 57.167. That is our Q3. So we check Q1. For us to get Q1, we take 3/4 of the total data, which is giving us 25. So we check according to cumulative frequencies. Where is the 25th accommodated? Where is the 25th learner accommodated? And so to get the 25th, then we have to check the first one according to the cumulative frequencies. We only have 6. In the second, we have 24. So the 25th is contained in this class. The 25th student is contained in this particular class, and this becomes our Q1 class. So we are going to use that Q1 class now. So Q1 becomes lower boundary shall be, the lower boundary of this class shall be 40 plus 41, because we are taking the lower limit here, which is 41, and the previous upper, which is 40. And you divide them by 2. We're getting 40.5. Plus a quarter of 100 minus cumulative frequency just before. You know, just before that there is a 24. Then now we divide by frequency of this class, which is 27, and we multiply by width of the class. This is 40.5 plus, a quarter of 100 is 25, and we minus 24, which is just 1. 1 times 10 over 27 gives us 0.3704. What does this become? We add 40.5. This becomes 40.87. Let me just use the 4SF like that. And also in the first one, I'll use 4SF. So we can now take the quartile deviation to be given by Q3, 57.17, minus Q3 minus Q1, 40.87, divided by 2. So 57.17, and I subtract 40.87, then I divide by 2, I will get exactly 8.15. So this is our quartile deviation. That is our quartile deviation. It's a very good question. So you're supposed to get all the quartiles. There are 3 of them. The middle one is called the median. And median is even studied in paper 1. That is form 2 work. You see? Thank you for continuing to join. Thank you for continuing to join. We are now going to part B of this question. Yeah, you can see we have some space here. Part B, which is Roman 1 and 2. We're taught to use a working mean. Working mean is also called assumed mean, capital A, of 55.5. Then we calculate the mean mark and also the standard deviation. So let's first know, what formula do we use for us to get mean? For us to get mean, we need to talk about assumed mean plus the mean of all deviations. So all deviations multiplied by each frequency out of the total frequency, like that. And how do we get the deviations? The deviations are gotten by each midpoint minus assumed mean. So let us get the deviations first. It can be small letter d or small letter t. So we get the deviation t. Allow me also introduce another horizontal line there. This way. Yeah, like that. So we can talk about deviation t, and I've given you the formula for t. T will be given by each midpoint times each midpoint minus. So t will be given by each midpoint x minus the assumed mean of 5.5. So we get the midpoints. Sorry for that. Midpoints means the limits added, divide by 2. 21 and 30, we divide by 2, 25.5. The next will be 31 and 40, divided by 2, 35.5, 45.5, 55.5, 65.5, and 75.5. So we have all the midpoints now. What about the t's? What about the t's? So t, every t, the first t shall be, we take 25.5 and we subtract 55.5. This is going to be negative 30, negative 20, negative 10, then exactly 0, 10, 20. So that's how you get the deviations. Each of the midpoints minus the assumed mean, just as I said there. So we are supposed to get now the total deviations. And for us to get the total deviations, we need each frequency times the deviation, frequency times the respective deviation. So let's work out that. So we start with the 6 times negative 30. This is negative 180. The next is 18 by negative 20. We get negative 360. The next is negative 10 by 27, negative 270. The next one is a 0, because anything times 0 is just 0. 10 by 10, this gives us exactly 100. 3 by 20, is that 60? Yes. So we can get the sum of all the deviations now. The sum of all the deviations. Allow me to rub this one because we've already worked it out. Yes. Like that. So the summation of all the FT, what will this give us? So I'm having negative 180, negative 360, negative 270, then positive 100 and positive 60. I'm getting negative 650. Negative 650. So for the mean, for the actual mean, we need to talk about 55.5, and we add negative 650 out of 100. Yeah. So 55.5, we are adding negative what? Negative 6.5. So what will this give us? The actual mean, 55.5, and we get exactly 49. So the mean of the marks that we have is exactly 49. Exactly 49. That is the mean. Then we get to standard deviation. For us to get standard deviation, call it S. For us to get standard deviation, we need the square root of variance. So the variance is usually given by summation of ft squared out of the summation of f, and we subtract summation of ft out of summation of f, this part also squared, then we take the square root of everything. Yeah. So the formula of variance, we take square root. So now, before we substitute, we get to the table, and we are getting to the table to work out what? Let's check that. We're getting to the table to work out the value of ft squared. Ft squared. F times every t squared, every deviation squared. So we start with the first one. Start with the first one. We are having deviation squared, which is giving us 900. Then times 6 is the frequency. So that is 5400. The next is negative 20 squared, which is 400, times 18. This is 7200. The next is negative 10 squared, it becomes 100. 100 multiplied by 27, so it becomes 2700. The next will automatically be a 0, because 0 squared, it becomes a 0. You multiply by this 36, it remains a 0. The other one is 10 squared, 100 times 10, the frequency, we get 1,000. Then 20 squared, we get 400. 400 should be multiplied by 3. We get 1200. So can we talk about summation of f times t squared? What do we get as the summation here? 5400, 7200. Then we are adding 2700. Then we are adding 1,000. Also adding 1200. This gives us exactly 17,500. Yeah, 17,500. I hope I've not made any errors. So 17,500 out of 100 minus, we had already worked out this part where we got negative 6.5 and we are supposed now to square it. You know, this part we have already worked out here. So we are only needed to square it. Then we take the square root, or you need a fresh substitution anyway, sorry. So we can have a negative 650 over 100. Then we square like that. And then we square just like that. Let us now work out this part. We divide by 100. This is 175 minus, when we take 6.5 and we square, I'm getting 42.25. So after taking the difference, I'm having the square root of 132.75. So our standard deviation is exactly 11.52. Yeah, 11.52. That is not the exact value. I've rounded it off. This one I have rounded off to 4 significant figures. Yeah, exactly 4 significant figures. A very good question on statistics too. So thank you for staying around. Thank you guys for choosing our platform. Please remember to subscribe, remember to share, remember to invite a friend. We are also inviting you to our model of purchasing airtime. Regardless of the network that you are using, as long as you are in Kenya, you just need to go to your Lipa na M-Pesa. Then the pay bill is already attached on this wall, and it is very easy to master. If you are a math student, a math teacher, a math parent, whoever you are, our follower, just go to your Lipa na M-Pesa, 737356. That is the pay bill number. Then after that, you enter the account. Now, the account number shall be the phone number that you're purchasing the airtime for. Could be Safaricom, Airtel, Telcom. After you enter that number, you proceed to enter the amount. You complete the transaction and you will receive your airtime instantly. So you are most welcome to that platform. We proceed with the paper number 19 on commercial arithmetic, and says that the table below shows the income tax rates for a certain year, and you can see the monthly income in Kenya shillings and also the tax rates as percentages. Now, a tax relief of 1162 Kenya shillings per month was allowed. He's also entitled to a pension scheme of 7.5% on his basic salary. In a certain month of the year, an employee's taxable income. Look at that. An employee's taxable income. Want us to understand that. In the 5th band was 2108 Kenya shillings. Calculate part A, Roman 1, the employee's total taxable income in that particular month. So this is what we are going to do, ladies and gentlemen. This is exactly what you are supposed to do. One thing that you're supposed to know is that we have different amounts of tax in different bands. In the first band, we shall tax 10, 164. 10, 164. In the second band, what are we taxing? So that is a 10, 164. In the second one, what shall we tax? We take the upper limit, which is 19, 740, and we subtract the upper limit of the previous 10, 164. This gives us 9576. 9576. And in the second, that is the second. So in the third, we take 29,316 and we subtract the previous limit of 19,740. That is again 9576. 9576 and we add. In the fourth, we need to take 38,892 and we subtract 29,316. This gives us 9576 again. 9576. So 9576. And finally, we are being told that in the fifth band, this guy, we're going to tax him 2108. Yeah. So what are we having is the total taxable income. So we take 10, 164 plus 9576 times 3. Then we add 2108. This is exactly 41,000. I hope the addition is very okay. It is my hope that we didn't make a mistake on that addition. You can even take, we've been told, when you are told that in the last band, there is 2108, then it is to mean the amount that is beyond 38,892 is just 2108. So you add, 41,000. That is the answer in part 1. That is the answer in part 1. Then we proceed. Remember, that was the tax, not tax. That was the taxable income in the fifth band. It was not the tax. It is the taxable income that lies in the last bracket. Then what are we being told to do now? We calculate the tax payable by this particular employee in this particular month. So we talk about from the first band. From the first band, it is 10,164 by 10%. 10,164 by 10%. What is this giving us? 10,164 by 10%, giving us 1016.4. Then in the second, we will talk about 9576 by, what is the rate in the second bracket? 15%. So times 15, that is a 9576 by 15 over 100. So I'm getting 1436.4. The next, which is the third, it's also 9576 at the rate of 20% according to the table. So 9576 by 20%. This is a 1915.2. In the fourth, we are having the same 9576 times, is it 25? Yes, 25 So 9576 by 25%. This is a 2394. And finally, in the fifth, we are already given the tax there. We are already given 2108. Yeah, that's the amount that lies there at the rate of 30%. So multiply this by 30%, 2108 by 30%. This is a 632.4. So now, after getting the taxes from each of the brackets, ladies and gentlemen, we can talk about the gross tax, which shall be now addition of the respective taxes from all the brackets. 1016.4 plus 1436.4 plus 1915.2 plus 2394.0 plus 632.4. So we are getting a gross tax of 73.94 and 40 cents. So 40. That is the gross tax. But now we need the payable tax, or rather the net tax, the payee. You know, there is a tax relief given per month. And that means we need to talk about now payee is gross tax minus relief. So minus a relief of what? 1162. So we subtract 1162. This gives us 62, 32.40. So this is now the net tax payable by this particular employee. We proceed. We are now in part B of this good question on commercial arithmetic. In part B, we are told that the employee's income included, a house allowance of 10,000 Kenya shillings per month. Then the employee contributed 5% of the basic salary to a cooperative society. Calculate the employee's net pay for that particular month. How do we get net pay? Net pay is given by gross income, everything that the guy earns, minus all deductions. Minus all the deductions. So can we first work on all the deductions? Let's first work on all the deductions. But another thing that you're supposed to know that this guy is contributing 5% of the basic salary, a basic salary that we don't know. So can we say this? That taxable income, check this, taxable income is usually given by basic salary plus allowances. And then something that we're supposed to know is that the pension scheme is not being taxed. You can't, the person is first deducted the pension amount, then now taxation takes place. And so we can now talk and say the taxable income that we have, which we will treat as our gross income, taxable income is given by a non-basic salary plus allowances, house allowance. We don't have any other allowance, but we subtract 7.5 of the basic salary, which is not part of the taxation. So 100 minus 7.5 may mean that we don't have 100% of the basic salary. It is 92.5 of the basic salary. 92.5% of the basic salary. So from this, we can get the value of the basic salary. Yeah, we can get the value of the basic salary. So it is not 100% of the basic salary, which is taxed. There is 7.5 that goes to pension scheme. So 92.5% of the basic salary is what becomes taxable income, then plus any allowance, and we have the allowance. So 41,000, we subtract 10,000 to give us 31,000 being equal to 0.925x. How shall you remain with x? By dividing through by 0.925. This is now 33,513.51. Yeah, this is now the amount of the basic salary. Now, after knowing the basic salary, we can again talk about now the deduction that we were after. Which deduction are we after? The deduction that we are after is the 5% of this basic salary. 5% of basic salary to cooperative society. So to the cooperative society, this is a deduction of 5% of 33,513.51. So there is a deduction of 5% of this, giving us 1,675.68. That is one deduction. The other deduction is the payee, and we have it there. Let me check any other deduction. Is entitled to a pension scheme. You know, according to the pension scheme, we have already not included it in the taxation, so it is automatically deducted. That one is not contained in the 41%. Therefore, the net income shall now be given by the net pay. The gross that we have is 41,000 minus all the deductions. The first deduction is the payee, 6232.4. 6232.4. And another deduction here of 1675.68. So what are we getting here? Remember, we said pension is not in the, it is not contained in the taxable income. So that is why we excluded it. It is already not inside there. It is not inside our taxable income. So I'm picking 6232.4 plus 1675.68. Then now we take 41,000 and we subtract this value. We get exactly 33,091.92 Kenya shillings. A very good question on commercial arithmetic. Very good. A very excellent question. Thank you. Thank you for following. Please remember to comment. I'm expecting you at the comment sections. Kindly give us your comment. Let's know whether you are learning with us. Yeah, please let's know that we are together. We are moving up to number 24. So kindly don't sleep on the way. Don't get tired. We are here until you get everything right. Number 22 variables, P and L, are such that P varies partly as L and partly as the square root of L. Determine a single relationship connecting P and L given that L equals to 16 when P is 165 and L equals to 25 when P is 254. Let us use the conditions provided here to find for some constants here. You know, already we are told that P varies such that P varies partly as L and partly as the square root of L, meaning that P equals to, we can have two constants, K by L and C by the root of L. At this point, ladies and gentlemen, we can now talk about the conditions provided here that P is 165 when L is 16. So 16 by K and C by the square root of 16, which is 4. This is one of the equations. Then P equals to 254 when L is 25. So 25 by K and the square root of L, which is 5 by C. Roman 2. We can use any methods to solve this. Allow me prefer the substitution method. Or, because we used substitution in the first question, number 17, allow me now in this question, ladies and gentlemen, allow me in this question to just use the elimination method, whereby in the first equation, we multiply, we want to eliminate C. I choose eliminating C. So the coefficient of C in the second equation is 5. So we multiply by 5. And equation 2, the coefficient of C in the first equation is 4. Everything by 4. So that the values of the coefficients of C may be equal. 165 by 5, that is 825, equals to 16 by 5. This is 80, the value of K. 20 by C. Then the second equation becomes 4 by 254, giving us 1016. This is equal to 4 by 25, I think that's 100. Okay. And this is 20C. So with these two, whereby the coefficients of C have been equated, we can now subtract corresponding terms, whereby 825 we subtract 1016, giving us negative 191 equals to 80 minus 100, giving us a negative 20, the value of K. And you see C has now disappeared. So negative 191 divided by negative 20, that's giving us 9.55 positive. 9.55. Now with 9.55 as the value of K, we can find the value of C by using any of the equations. If I prefer using equation 1 to be 165 being equal to 16, the value of K, plus 4, the value of C. Can we remain with 4, the value of C there? Then we take 165 minus 16 multiplied by 9.55. This is going to give us 12.2. At this point now we can remain with C by dividing by 4 and we get 3.05. So with these constants now established, we can now write this equation, which is now the relation containing or connecting P and L. So P equals to K, which is 9.55, the value of L, plus C, which is 3.05, the square root of L. So we have now the final equation that connects P and L, properly expressed. You see that? So that is on partial variations. We check at B of this. Now, three quantities P, Q, and R are such that P varies jointly as Q and the square of R. Given that a decrease of X% in Q and a decrease of 20% in R results in a decrease of P by 40%, find X. All right, find X. Then part B, calculate the percentage change in P, given that Q is increased by 10, R is increased by 20. So please allow me, because number part B, Roman 1 and Roman 2 are the same, only that the unknown is changing. We are already given the percentage change. To find percentage change of the quantity which is not the formula. This is what we are saying, for instance. P varies jointly as Q and also as the square of R that way. So changes in, okay, with P equals to a constant Q R squared. So with changes in Q and R, P will be affected. So we are given the change in P already, but the change in what? Just a minute. The change in Q is unknown. Or we can simply make Q the subject. If Q is made the subject, then Q equals to Q equals to remain with Q there, we are already having P. So we need to bring the constant and R to be the divisors there. Yeah, like that. So it's like we are being told now to mention the change that we will get in Q when R and P are changed. I think I've made it simple now. Yeah, we've made Q the subject because we want the percentage change in Q. That will correspond to 20% decrease in R and 40% decrease in P. So this is the original Q. So what about the new P? Change in P shall be, P is decreasing by 40, so it becomes 60% of the original P, which is 0.6 original P. The new R shall be decreasing by 20, R becomes 80% of original R, making it 0.8 original R. So the new Q equals to P 0.6 of original P out of K multiplied by the new R squared. So 0.8 and we square like that. So with this now, we can proceed with our expression now. Percentage change in Q. Percentage change in Q. Percentage change in Q will be given by the new Q minus the original Q out of the original, and we multiply by 100. Yeah, should be original, the new minus original over the original. That's how we get percentage changes. So with that, we can now talk about the new Q. This value can be gotten 0.8 when squared, 0.64. So 0.6 out of 0.64. You see, this is exactly 0.9375 I'm computing this thing, the new Q. I'm computing that. P over K R squared. That is the new value of Q minus P, the original, K R squared. Then out of P, out of K R squared. When you factor out, these will be multiplied by 100. So when we factor out P out of K R squared, we shall remain with 0 point. 9375 minus 1 times 100, of course, over 1. So remember, at the denominator, we are writing KR squared. So this and this shall cancel. And we will have, when we subtract 1, then we multiply by 100. We shall have negative 6.25%, meaning that Q decreases. Q decreases by Q. The negative is for decrease. The negative means a decrease. So when a percentage change is negative, it means a decrease. 6.25%, which is our value of X. 6.25%. So the percentage decrease in Q is 6.25. So when you approach it without making Q the subject, you shall still get it, but please be assured that you will struggle. But when you make it the subject Q, it really becomes very simple, just the way I've done it. So part 2 now, it's very direct now. It's the one that shall use this expression now. P equals to a constant Q R squared. Percentage change in P, given that Q increases by 10%, R decreases by 20. So the new Q shall be, Q increases by 10, so it is 110% of original Q, which is 1.1 original Q. Then R, the new R becomes, R is reduced by 20%. So it's 80% of original R, 0.8 of original R, meaning that the new P shall be constant multiplied by the new Q, 1.1 of original Q, times 0.8 R squared. The new P is going to be 1.1 times 0.8 squared. This is 0.704, a constant, times Q times R squared. Can we now talk about percentage change in P? The percentage change in P will require the new P minus original P out of original P, then we express as a percentage. So with that now, we will talk about 0.704. K Q R squared minus the original K Q R squared out of the original K Q R squared. Then we multiply by 100. So we factor out from the numerator K Q R squared. We remain with 0.704 minus 1 out of K Q R squared. So this cancels. Remember, there is times 100. And now when we subtract 1, we get a negative. Then by 100, this becomes negative 29 0.6%, meaning that P is decreasing. A negative percentage change means a decrease by 29.6%. So the percentage change is a decrease of 29.6%. This is a very good question on variations. A very good question on variations. So thank you for following. Please remember to subscribe, remember to share, just to invite your great friends. Please don't be a beneficiary of shifting grades. Then the brothers and sisters that you school together are not aware of such a deal. Imagine programs like these ones now for junior school in mathematics, in sciences, and in languages. Imagine us handling them without your friend. What are friends for if you can't invite them to educative platforms? And for senior school, we still have their independent timetable. Reach out through our number on the poster, and please remember to subscribe to this particular platform. By the month of August, very specific, we shall be handling all the subjects using NEC examiners, people that are qualified, people that have been marking the examination papers for quite long. They will give you the structure of every paper. They will give you every secret that is needed for you to succeed. So kindly reach out through our number so that you may be in our platform, so that you may know how to go about this particular program. Otherwise, we are wishing you well, and we request you to stand with the best platform towards our silver platter award, because we are almost hitting the first 100,000 subscribers. Please be one of us. 21 on sequences and series. Now, the 5th and the 10th terms of an arithmetic progression are 18 and -1 respectively. Determine the least number of terms that must be added together in the progression so that the sum is negative. All right. We are given the 5th and the 10th. How do we get nth term in a given progression? Generally, the nth term is usually given by first term plus n minus 1 multiplied by d. And if we know this, then we can say that the 5th term, which is 18, is given by a plus, because it is 5th, 5 minus 1 multiplied by unknown d. So 18 equals to a plus 4, the value of d. This becomes equation 1. The 10th term is a -2. -2 equals to first term plus 10 minus 1, according to the formula, 10 times d. 10 minus 1 gives us 9 times d. You see? So we are already having two equations. We call them simultaneous because the values of a are the same. The coefficients of a are the same in the two equations. The coefficients of a are the same in the two equations. Please allow me subtract downwards. 18 minus a -2. 18 minus a -2 becomes 20. This is equal to a minus a, that one cancels. 4 minus 9 becomes a -5, the value of d, meaning that d shall be given by dividing through, we get a -4. So the value of d is -4. Now with -4 at that point, we can get the value of a. 18 equals to a plus 4 by d. This is -16, meaning that the value of a shall be negative 16 will be added. So 18 plus 16 giving us 34. So the first term is 34. The common difference is negative 4 in this particular progression, which is arithmetic. So now with this, we are able to talk about addition of terms. When you start adding the terms, it will continue until the terms are negative. We start with 34 minus 4. The next one becomes 29, 25, or 26, like that, as you subtract 4. And therefore, with some time, the sum will become 0 and then transition to negative, because the last integer, then you get to zeros. Okay, the last integer, then you get to the negatives is a 0. So the sum will be positive for some number of terms. But when you continue adding a bigger weight of the negative numbers, the sum also becomes negative. Are we together on that? The first few numbers, like 34, the next one will be 30, the next one 26, the next one 22, like that. So it is a decreasing arithmetic progression because the D is negative. So the first few numbers will have a total of positives. But as the number transition to negatives, because they will eventually become negative because of the nature of the D, the sum will also become negative eventually. But before it becomes negative, we know that the last integer for this sum to transition is a 0. So can we check the numbers that will give us, the number of terms that will give us a sum of a 0? Remember, sum of n terms is given by n over 2 into 2a plus n minus 1 multiplied by d. And now we need a sum of 0 equals to a certain number of terms over 2 into 2 by a. A is 34 plus n minus 1 multiplied by negative 4, which is our d, like that. 0 equals to n over 2 into 68 minus 4n plus 4. It becomes a positive, yeah. So 0 equals to n over 2 into 68. Okay, instead of 68, when we start grouping terms at that point, when we start grouping terms, we shall talk about, is it 72? 72 minus 4n, like that. So we can open the brackets now. 0 equals to 72 over 2, it becomes 36n, then minus 4, and the value of n is now squared. So 4n squared can become positive on this side, equals to 36n. We can divide by n so that you get 4n equals to exactly 36. How do you get the value of n? By simply dividing by 4. I hope that part is properly considered and properly multiplied. Want to hope that it is properly multiplied. Okay, so the value of n is 9. Now, if the value of n is 9, now you will just allow me to talk about just a minute. Okay, we are opening the brackets at this point. At this point, let's take it slowly. This is 36n minus 2, the value of n squared, so that we have 2n squared and 36n. You divide by n, you discover that 2n equals to 36. No, it should be 32. Let me check, sorry. 72 over 2 is 36, yeah? So when you divide by 2 now, it has to become 18. So the first 18 terms, the first 18 terms will give us a sum of 0. Now, after getting a sum of 0 now, you should know that the next addition now will take us to the negatives. The next additions now should become negative. And therefore, we need at least 19. At least 19 terms. So 19 terms is what will give us a negative sum. 19 terms is the final answer. That is what will give us a negative sum, because exactly 18 terms are taking us to a sum of 0, meaning that onwards, the sum will become negative. Part B of this, let's check part B. The second term and the fifth terms of the above progression, the above, which is the above progression, the one we've discussed, with a first term of 34 and a common difference of arithmetic. Now the second and the fifth, they form the second and the fifth of a GP. Find the first term. Find the first term of the geometric progression. So let us check here. What is the second term in our AP? The second term in the previous AP should be 34 and we minus 4. It becomes 30 because the common difference is a negative 4. So from 34, the next term is the second one, which is 30. Then the fifth. Now the fifth term is going to be equal to first term plus 5 minus 1 multiplied by negative 4. So the fifth shall be 34, then minus 16. Yeah, because that is 4 by negative 4. Get 16. So are we getting 18? Yes. It's 18. So this is now the second in a GP, and this is also the fifth in the GP. You know what a GP means? A geometric progression, whereby from one term to the next, we have a common ratio. Therefore, now we are supposed to talk about, the ratio of the second and the fifth. When we take the fifth number, which is 18, and we divide by the second number, which is 30, we are supposed to get, nth term in GPs. In a GP, nth is given by A, R, n minus 1. Therefore, if it is the second term, it becomes A times R. And if it is the fifth, it becomes A, R, power 4. Because it is the fifth, it is now power 4. Second, R is power 1. So because we have started with the fifth, 18, we talk about AR power 4 out of A R. So from these, by 3 can get 6, or we can divide by 6, we get 3, and by 6 we get 5. This is equal to A can simplify so that it gives us, and 1R simplifies to give us R power 3. So R power 3 equals to 3 over 5. 3 divided by 5 is 0.6. So R power 3 equals to 0.6, meaning that R is the cube root of 0.6. So R is approximately the third root of 0.6. Let me have it like that. Yeah, let me have it like that. So now, if that is the value of R, can we agree this? Can we agree this? That the second term, which is A times R, allow me draw like this, A times R, whose value is the third root of 0.6, equals to, second term was what? Second term is 30, equals to 30. So that the value of A now becomes 30 divided by the third root of 0.6. So I will take 30 and I divide by the third root of, and I'm getting exactly the first term is 35.569. Yeah, to 3dp. To 3dp, that is the first term. To 3dp, that becomes our first term. So that is how the question is supposed to be done. It's a very good question. That is now the first term. Yeah. First term times R, and R is here. Should give us 30. Should give us 30. Like that. Number 22, a question on vectors. Vector 2 actually. The diagram below, OP equals to vector A. And OS equals to vector B. This is vector A. This is vector B. Okay. Then SX, X is this meeting point. SX equals to H multiplied by SP, the whole vector there. OQ equals to 3A, meaning that if this was A, then we have 2A like that. From P to Q is 2A, because O to Q, it is 3A, and already there is A up to P, then that is 2P, is what I mean. So that we have the whole of OQ becoming 3A, then we need to talk about A and 2A, like that, trying to interpret the instruction. Then 2B is what? QR, the value of B, like that. This is a very good question. I'm actually liking it already before we even compute. I'm already in love with the question. Let's proceed, ladies and gentlemen. Let us proceed. We are talking about expressing SP in terms of A and B. SP, S to P. So SP requires us to move from S to O, then O to P. Now S to O is the reverse of OS, so negative B plus the value of vector A. So we can now rearrange and have A minus B like that. That is the expression. Can we proceed with expressing this? It's a very good question. Vector OR in terms of A and B. Vector OR. You know, for us to have vector OR, we need to move through OQ, then U to R. This now becomes OQ is 3Q plus 2B. It's already done. Very simple. Yeah, it's already done that way. You can have the vector notations at this point. It's very key. In part B, Roman 1, we are told to show that vector OX, show that vector OX is equal to H vector A plus 1 minus H vector B. So we want to express vector OX using the expression which was having constant H, and this is it. So OX is equal to, we want to accommodate which vector? The vector that has H, and that is SX. So to contain SX, we need to talk about OS plus SX. Then OS is vector A. Is it A or B? Let's check. That's vector B plus SX. SX is equal to H SP, and SP is here. So H A minus B. H SP, and SP is A minus B. A minus B, yeah, instead of SP, A minus B like that. So now we can talk about vector B plus H vector A minus H vector B. We can now have, let me underline here. Let me just underline this part so that we have HA plus B minus H vector B. I'm just grouping the terms with vector B's together, so that now at this point we can say the vector OX, ladies and gentlemen, can be given by H vector A. Then vector B is factored out, so that will remain with 1 minus H, and vector B is factored out like that. So with that expression now, we've already shown, we've already proven that OX equals to what had been typed there. It has already been proven, mathematically proven. That's a very good question, very unique setting. Look at part 2 of the same. Given that OX is supposed to be OX, sorry for that typing error, equals to K, the vector OR, find the values of H and K. So vector OX again equals to K multiplied by vector OR. Where is OR? We've already worked out OR. It's here, 3A plus 2B. That is a second expression of OX, which is now equals to 3K vector A plus 2K vector B. This is a second expression, and we had the first expression here. So for us to find, because these are two expressions that are giving us vector OX. Vector OX has been expressed in two different ways. So to find the constants involved, we need to come up with simultaneous equations such that the coefficients of each vector will give us an equation. So the coefficients of A, let me begin with the coefficients of A. In the first equation, we have H equals to coefficients of A in the second. Coefficients of A in the second is 3K. That is equation 1. Equation 2, we need to say the coefficients of B, which is a 2K, equals to coefficients of B in the second one, or in the first one. 1 minus H. This was 1 minus H, sorry. 1 minus H. That's how we are supposed to equate them. So this becomes our second equation, and we solve the two simultaneously. Solving the two, we can now use a substitution, because from equation 1, H has been expressed. Then equation 2 becomes 2K equals to 1 minus, instead of H, we have 3K. That. So this can become 5K equals to 1. So that the value of K equals to 1 over 5. We divide by 5 through. 1 over 5 gives us K. With 1 over 5 as the value of K, what will be the value of H? 3 into the value of K, which is 1 over 5. So the value of H is 3 over 5. Now we are having the value of K and the value of H. Very easy to work out. Application of simultaneous equations. And that's why I will keep telling my followers and my students that please beware of simultaneous equations. Please beware of quadratic equations. These are equations that will be widely applied even in topics that are not related to simultaneous equations, quadratic equations. So please just know the basics by simply being aware of how to solve them, because anytime they show up in various topics. Like this one is vectors and we are solving simultaneous. We also solved simultaneous in variations. We are checking the part C of the same question. Part C of the same question. Part C of the same question. So we read it together. Part C, we read it. Determine the ratio OX to XR. OX to XR. You know, we've been told that OX equals to, according to this, K or R. K is 1 over 5 of O R. K or R. Therefore, there is something here that we are supposed to understand. OX equals to 1 out of 5 of OR. OX equals to 1 over 5 of OR. OR is the whole length. So a fifth. 1 out of 5 proportions of R. OX is 1 proportion out of 5 proportions of OR, meaning that we remain with 4 proportions here. 1 out of 5, a fifth of the whole OR, which is 5, and we're already talking about 1 proportion out of 5 proportions, meaning that from X to R, we remain with 4 proportions. That is what it means by 1 over 5. 1 proportion, and the total are 5, meaning that from X now to R, the remaining are 4. And so we can say that OX XR is 1:4. So OX to XR is 1 and 4 proportions, like that. So that is the ratio. That is how you are supposed to state it. A very good question, ladies and gentlemen. Very good. Thank you for following. Thank you for following us. Number 23 now. The figure below shows a quadrilateral. PQRS inscribed in a circle center O. You know, such a quadrilateral is called a cyclic quadrilateral. A quadrilateral whereby the four vertices are touching the circumference of the circle. The radius is 10.5 as you can see, and the angle RST. RST is 80. RST, we have to be very careful there. This one. This is equal to 80. All right. Can we proceed? Yes. PS equals to 8.5. PS, this length, 8.5. Then RT, R to T, this length equals to 8 centimeters. How RT is 8 and PS is longer, 8.5, I don't know, but the diagram is not drawn to scale. So let us be flexible and reasonable. The diagram has not been drawn to scale. Now, giving reasons, find the size of the angle PQR. PQR, the angle at this point. Yeah, the angle at that point. We are going to solve that one together, and it is my hope that you guys shall understand. What we are going to understand is that using the straight line PST, this inner angle here should be 100, because along a straight line, we expect 180. Then now, this being a cyclic quadrilateral, then we can agree that opposite angles in a cyclic quadrilateral are supplementary. Therefore, we take 180 minus 100. That angle becomes exactly 80. Opposite angles in a cyclic quadrilateral, that is the property we have applied. Opposite angles in a cyclic quadrilateral are supplementary. They add up to 180. That is the mathematical principle that we have applied at that point. Something else that we are finding is the obtuse angle POR. When you talk about obtuse means an angle that is an angle that is greater than 90 but less than 100. So POR, now we mean this one. We don't mean the reflex. We are not talking about the reflex. We are talking about the obtuse, so the inner one. So we say that the angle should be 80 times 2. The angle should be 80 times 2. 80 times 2, 160 degrees. The angle at the center, is usually twice the angle at the circumference. The angle at the circumference. Is that clear? The angle at the center is twice the angle at the circumference. Angle at the circumference, that way. So because we said this is 80, then the angle at the center, because they are both subtended by the same chord PR. So angle subtended by the same chord one at the center of a circle, the other one at the circumference, then you discover that the one at the center is twice the one at the circumference. The same question, but now the same question, but now in a Roman 1 of part B. Find the length of ON. The length of ON, you know, this angle can be found to be the angle here, because we have 160. This is 80 on its own. So we have an angle of 80, and we have an hypotenuse of 10.5, which is the radius. This is according to triangle ORN. ORN. So we can apply some trigonometry there. And can we talk about, because we are interested on this length ON, and we have the adjacent angle, we talk about cosine of 80. Cosine of 80 is equal to the adjacent length, which we don't know, out of the hypotenuse, which is known. So to remain with x, we need to multiply through by 10.5. Yeah, the cosine 80, cos 80. So x, which is our ON, equals to 10.5 cos 80. You just type in your calculator that, and you get exactly 1.823. 1.823 centimeters for significant figures accuracy. We are at part 2 of the same question. We need to find the length ST. Length ST. Where is ST? The length ST. Oh, yes. ST is here. We have ST as this point. Can call it length Y. This length is not known, but you know, there are some angles that we know in this case, and we can use the known angles and the known lengths so far to find the missing lengths. Yeah, to find the missing lengths. So we can first of all find the length PR, which is the same as PQ. Can we find PR? Yeah, let's find PR. Let's find PR first. And for us to find PR, you know, you need the length PR. Just a minute. Just a minute. For us to find the length PR, you know, there is already the lengths that we have. We already have 10.5 and 8 there. This is 10. This is also 10. So can we talk of NR first? Being equal to, we use Pythagoras theorem, 10.5 squared minus ON squared, which was 1.823, also squared. Then we find the square root now, Pythagoras theorem, finding NR. So NR shall be, NR is going to exactly be, let me find that angle. Let me find that angle. So we need 10.5 squared minus 1.823 squared. Then we find square root. I'm getting 10.34. That is NR, meaning that the whole PR can be found by 10.34 by 2, giving us 20.68. 20.68 centimeters. So we have the length of PR, sorry, as 20.68, like that. We also have the length 8. The length 8. We have the length 8. Yeah. So the length 8 is also known. And on the lower side, PT, we have part of PT known. If part of PT is known as 8.5, then we can get the remaining part. And it will be very easy to do that. So now here, we need to apply. When we take, look at these. When we take a 20.68 and we divide by the sine of 80, the sine of 80 is the opposite length. Just look at that. Look at triangle. We're considering triangle PQR. And with the triangle PQR, we are going to apply the sine rule. We are already having 80 at this point, and we have the opposite length. So PR out of the angle at Q, the sine of the angle at Q, PR, look at this, PR over the angle at Q, sine of the angle at Q, it will be the same as, the length QR, which is unknown, out of the sine of the opposite angle, which is the angle at P. So now with this, allow me to talk of PR. The length PR, we have already found it as 20.68 out of sine of 80, the opposite angle. This is equal to QR out of the sine of 50 degrees. The angle here is 50 degrees because this is 10, and we are having 80 there, that's 100. So the remaining is really? Okay, just check this. This is according to this triangle. We are already talking about 10, 10. And this is 80, 80, like that. So this particular, these are two radius, yeah. So the angles there are equal. And we can talk about the angle here being, we take 100, 180 minus 100, 80 divided by 2, we get 40. So this is 40, yeah. I've seen, yeah. This is 40, and this is 40. I wanted to show you where 50 is coming from. So the whole of this angle at B is 50. Yeah, 50 because of 40 and 10. So QR shall be, the length of QR is going to be 20.68 sine 50 divided by the sine of 80. See, I'm getting 16.07. 16.09, sorry, when I round off keenly, 09, like that. So QR is 16.09. QR 16.09. RT8. So now we can consider intersection of chords. Chords intersecting externally. We usually say the total length QT times RT. QT times RT should be equal to the other chord PS times ST. PS times ST. So here QT equals to 16.09 plus 8. That becomes 24.09. 24.09 multiplied by RT. RT is 8. This is the same as PS, the length P to S should be 8.5 plus Y. 8.5 plus Y multiplied by the outer portion, which is Y. Remember, we let it to be Y, like that. Yeah, we let it to be Y. So now with this, you know what we are looking for at the end of the day is that value of Y. So this is going to be times 8. I'm getting 196, 192.69 equals to 8.5Y plus Y squared. This is a quadratic one. It's a quadratic one, so we have Y squared plus 8.5Y minus 192. 192.69 equals to 0, like that. So to solve quadratically, allow me use the completing square method, whereby I need Y squared plus 8.5Y equals to 192.65. Remains positive on that side. And we add constants to both sides. Which constants do we add to both sides? Constants such that b over 2 squared. Yeah, 8.5 divided by 2 and we square. So we get 18 point, okay, here's a fraction. 18 and 1 over 16. And also we add 18 and 1 over 16. That is b over 2 squared, like that. So now we can factorize the left-hand side to have y plus the square root of this is 4.25, rather 4.25 squared, that is the factorized, equals to, we have 192.69 plus 18 and 1 over 16. This is a 210.7525. So can we talk about square root of both sides? So that we have y plus 4.25 equals to square root of the other side, which is 14, a plus or minus 14.52 to 2dp. How do we remain with y? Two options, either 14.52 minus 4.25. What will this give us? Minus 4.25. This gives us 10.27. 10.27. 27 centimeters. Or we take negative 14.52 minus 4 point, and that will give us a negative value of y. This is our ST because the negative value should be ignored. So we stick to the positive value of y. There are two values of y, but we stick to the positive one because it is a distance that we are dealing with. That's a good question. Very involving. It really needs one to be having some good content on what we are dealing with. Yes, now number 24 and the last. 24 and the last. 24 and the last. Construct a triangle PQR such that PQ equals to 7, QR equals to 5 centimeters, and PQR equals to 30 degrees. 30 degrees. Let's do this triangle together. Let us do the diagram together. It's a very good question on LOCI. So I will start by doing a straight line. So I mark point P on one side. Then now using an arc of 7 centimeters, I mark off the other side. That becomes our Q. So we are having 7 centimeters like that. Allow me to prolong this length kindly. Let me produce it like that. Yeah, we are having PQ. From this, we can also talk about the angle at Q to be equal to 30. Okay, we've not been told to fail to use a protractor, but it is good for you to know how to construct special angles without protractors. So for us to construct 30, we need to stand at Q. We use an arc like this. Then standing on the arc at the line, we mark off on the upper side, such that when this is produced, we get 60 degrees. Then now standing at Q, you bisect this particular 60. So you stand here, you make an arc, stand on the arc again, you produce another one. That will give us 30 degrees. Now you produce the angle of 30 degrees comfortably. This is exactly 30 degrees like that. So with 30 degrees like that, we need to know that the length from Q to R is 5 centimeters. So now we measure 5 centimeters from Q. Yeah, 5 centimeters from Q, and we mark on this line 5 centimeters. This becomes our R. And when we drop R to P, we should be having our triangle like that. So we got our triangle PQR. Very easy to construct. PQR. Now we get to the other instructions. Roman 1, this is part B now. On the triangle, construct the locus of a point N. A point N, a point equidistant from P and R to meet the locus of a point Z. A point equidistant from PR and RQ at T. Then you measure QT. One thing that you're supposed to know, this now is these are two loci which have been discussed on the same question. A locus of N, these are points that are equidistant from two fixed points. Two fixed points, it means perpendicular bisector of a line. Though I'll be discussing loci later, that is perpendicular bisector of PR, perpendicular bisector of PR, there will be that line, that perpendicular bisector will contain all the points that are equidistant from P and also R. So PR should now be bisected, and it's being bisected perpendicularly. So PR is being bisected perpendicularly. So I want to raise a perpendicular bisector to PR. I hope you know how to bisect perpendicularly. I hope you know that, how to bisect perpendicularly. So this perpendicular bisector now, I'll give it a blue. This is the locus of N. Yeah, a perpendicular bisector to PR. That's the locus of N. Then when we talk about a locus of points that are equidistant from two lines PR and RQ, to R and RQ, that means angle bisector. Angle bisector of the angle between PR and RQ. PR and RQ, angle bisector. So we bisect the angle at R. We bisect the angle at R. We split it into two. The angle at R into two. So we're supposed to talk about bisecting an angle, whereby you stand at R, you make an arc, make another arc. So standing on those arcs now, you can make an arc up there and another arc at this point. Then you produce the line through R. The line through R, and it will give you a bisector of that particular angle. So this is now the angle. This is the locus Z. Z is the locus of all the points that are equidistant from PR and RQ. PR and RQ. So we have them meeting at T. They should meet at T. Then when they meet at T, we measure Q to T. Then from Q to T, you need to stand there using a divider. You stand at T, you open it to Q, then you transfer it to the ruler. So Q to T is exactly 4 centimeters. So you can have 4 plus or minus 0.1 centimeters. So the people with 3.9, others 4.1, we shall consider them after measuring that. Can we check the other instruction now? Construct the locus of a point M such that the area of triangle PMQ equals to 10.5. On the same side of R, we also construct the locus of point W on the same side of R. Yes. So now we have again two instructions, two different loci again, two different loci. So when we are talking about area of PMQ, now M is a point. M is a point, and it is a point such that the triangle PMQ will have a radius of not a radius, sorry, area, half times a base of 7 times a known height. Yeah, PQ is already 7. PQ is 7. So M is supposed to be a certain height from PQ. A certain height from PQ. So how do you get H? unless you take 10.5 and you divide by 3.5. This is exactly 3 centimeters. So this is called parallel line loci. Parallel line loci or locus, whereby we now need to draw a parallel line to PQ, which is 3 meters away. 3 meters away. So 3 meters either above or below. The best way of constructing the parallel line is raising a perpendicular at P and you prolong it. Then you also raise a perpendicular at Q. You extend it to the lower side. Then now, standing on at P, you measure 3 centimeters above. Standing at Q, you measure also 3 centimeters above, like that. So when you connect the two marks, now, 3 centimeters from the line PQ, you'll get the locus of M. So this is the locus of M. It is, it is exactly 3 meters from PQ. And when you construct another triangle P, then to M and down to Q, that is 3 centimeters away, the area shall be 10.5 because the base is a constant 7.5. And you do the same on the lower side because you had not been limited on the side on which to do that. It can also be on the lower side. So 3 centimeters on the lower side, you mark 3 centimeters at Q on the lower side and you mark. Then you produce the line. Yeah, you produce the line. Now this is going to be, again, a possible locus of M. So the locus of M, they are 2, either sides of PQ, like that, on either sides of PQ. Now we are checking, and this question is really very, very comprehensive, almost involving all the types of loci. Because now I can see we started with the perpendicular bisector of a line, locus, angle bisector locus. We are now on the parallel line construction locus. And this is what are we seeing here? This is the constant angle loci. The constant angle loci. On the same side of R, construct the locus of a point W such that the angle PWQ equals to 60. So with PQ, we need to construct a circle locus of 60 degrees. What you need to know is that, I'll do a sketch here so that you people may understand. But the point is, with PQ, we need on the upper side where there is R, we need to construct a circle such that on this circle, we can produce an angle of 60. We can produce an angle of 60. Now, for us to produce an angle of 60, it definitely means that we need to be having a center. According to angle properties of circles, we need to be having a center. We need to be having a center with 120. We need to be having a center with 120. And for us to have a center with 120, then it means because these are 2 radii, then the base angles here need to be 30. They need to be 30 like that. And as you can see, PQ is a chord to the circle. So we can start by constructing the two base angles of 30 so that after intersecting, they automatically give us a center where there is 120. Now using that center, we can call it center O, and OP or OQ as the radius, we can now make our circle. Yeah, we can now make our circle. Therefore, at that point, we need to start with the base angles. Remember, alternatively, because PQ is a what? PQ is a chord. This is P, this is Q. We need to know that any perpendicular bisector of a chord passes through the center of a circle. So if this is 30 degrees, when we bisect PQ, this bisector of PQ shall pass through the center. That means wherever you meet the 30 degrees mark is the center. And because we are already having 30 degrees at point Q, we now need to bisect PQ perpendicularly. So if we bisect PQ perpendicularly, shall pass through this point. If we bisect PQ perpendicularly, let me show you. We shall have that bisector passing through the center. The bisector will pass through the center. So after the bisector has passed the center, it means the center can now be identified as center O. So the circle can now be drawn. The circle can now be drawn. So I standard that particular center. I use the radius to come up with this particular circle. To come up with the circle. So let me use the radius OP. So I stand at the center and I produce my circle. It might not be very perfect, but it is what you're supposed to do. It is what we have. So that is our locus now. This is the locus of what? The locus of W. So the locus is called W. Along W, that circle locus, anywhere along that we get, we shall get 60 degrees using PQ as the base. So if that is known, then we have already done part 2. That is a constant angle loci. The last part. Now another point Y is not more than 3.1 centimeters from Q. It is not 3.1 centimeters from Q by shading the locus of Y. Show by shading the locus of Y. Y is not more than 3.1 centimeters. Sometimes we talk about the locus of points that are at a certain fixed distance from a point. So from Q, when we talk about 3.1, we need a circle such that any points from Q to that circle, they are 3.1 centimeters away. But now that we don't need them to be more than 3 centimeters, 0.1, then we shed the inner side. So a radius of 3.1, then we do a circle. A radius of 3.1, then we do a circle. So we measure a radius of 3.1 using our compass. Sorry. You know, the airtime wants to market itself. Sorry for that. Okay, now using a radius of 3.1, we stand at Q. 3.1, stand at Q, and we make a circle. Like that. So along this circle now, the points there are exactly 3.1, but now we don't need the points of y to be beyond 3.1. So it should be 3.1 and below. That means on the inner side now, we have y. So y shed inside the circle now. Guided by the circle, we shed. Yeah. Guided by the circle, we now shed this, like this, that way. So we shed like that. A very good question, ladies and gentlemen. I've actually liked the question. I've interacted with the construction, and I can say this is a well-set paper. Generally, I've also interacted with the section A. It's a well-set paper. So thank you so much for following. Please remember to subscribe. Remember our programs. Reach out using the number which is on this poster so that you get enrolled to what we are doing around. Otherwise, thank you so much and welcome back again.